it better than either of these two ways that you've seen in videos, but I don't have a video of me doing it. So Max is going to take a video of me doing it, okay? So that I can post it later. So that's why he's talking now. So what I wanted to make sure, so what I like to do is do a fairly simple problem, but one that you can't look at it and just immediately see the answer. I'm not sure why this is not working. Projector, so I'm going to project the actual thing. If it will let me. Okay, so here's a piece of code, and the goal today is for you to do this Bernstein lab, right? It's a really good practice showing you how to compare iteration, and then it shows you several different kinds of recursion. Now, the only thing that you really have to turn in is the searcher PDF of you trying to trace out searcher. And the reason is because that's a really good canonical searching algorithm, okay? That's a real binary search algorithm, I believe, okay? When I looked at it. It will also be somewhat applicable to what you're doing for the next PA. And the next PA is listed. I haven't put it on Canvas yet, but it's available already. The final due date will be next Friday, not this Friday. This Friday you'll have the quiz, which I did put up, okay? So being able to understand recursive functions for that quiz and also for the final exam and for the PA is going to be really important. Yeah.
Is it worth it to start like working on that PA, or is it going to be like changed a lot?
No, this one is much more set. We have a kind of a faculty apology for that. On the other hand, it's very realistic coding when we go off in the real world, but this should be good. Okay, it's really a similar one to what was done before with just an addition that's pretty straightforward. Okay, and it's going to be a lot less code, intentionally a lot less code, but you'll need to, it also is one of these things where the recursive part, you either get it right or you get it wrong. So there's not a lot of in-between partial credit. So it's important to start it early so that you know that you've gotten it, okay, and that you can get appropriate help. One of the best things to do to help is to do recursion problems in coding that. I cannot emphasize enough how much doing all kinds of problems, thinking about how they work and what they look like, and why, kind of trying to see patterns in certain certain ways to solve it, that really is what helps. If you just sit there and beat your head against coding bat problems, it's not going to be super helpful. But if what you do is you start to try to recognize patterns and different approaches to solving them, it's really, really helpful. So do a coding bat problem by first trying to write it out and then see what you did wrong. See what your common mistakes are. So for example, if we look at this recursive function here with this string, it's maybe not completely obvious what it does right at first. But what it's ending up doing is that if it's 0, right, it just returns the empty string. Otherwise, it's going to get that first letter and put it on the end, or the first character and put it on the end. And then it's going to recursively do something to this part. And so can you see that it's probably going to be reversing this string? Okay. So we kind of know from that then what we're going for, and you'll notice that this is something where we just have one recursive call, right? There's some examples in the text where you have multiple recursive calls. So the way I like to trace things is I like to start out with saying, okay, I have a recursive function string s. What string should I do? Maybe 3 letters long so that we don't have to spend too much time, but you get the idea?
Dog.
Dog, okay, all right. So let's say our recursive, and I'm just going to call it RF, okay? So that I'm not spending so much time writing. You can do the same thing when you're tracing, because I'm not grading you on that, right? Your grade is gonna be on, were you able to answer questions like how many stack frames? What's the output, right? How many times was the function called? Okay, so if you start out saying, I'm gonna call a recursive function with dog, okay, and I'm gonna draw a box around it because it's the call. And then anything I write underneath here is actually going to be what I'm computing and part of that stack frame. So this box is kind of representing a stack frame and a call to me because there's a one-to-one mapping between calls and stack frames, right? All right, so here I can look at this and I can see if length equals 0, that's not true. Otherwise, what I need is first equals s substring. So substring 0 to 1, so this is going to be D, right? And it's a string, and then rest is going to equal OG, right? Okay, am I good with that? And now what I'm going to do is it's going to say, I'm going to return, so I might do something like this, kind of like Dr. Fox does, and oh, I need to call this again, right? Because it's going to be this call plus first, so I'm going to put my D in there right now when I know and I'm thinking about what it is. So now I have to call this again. So now I'm going to do the recursive function call. I'm making it in a box so that I can see it easily. And in particular, now I'm calling it with what? The rest. So I'm calling it with OG. And again, now I'm going to say first. What's the first one? Well, that's here O, right? And the second, or the rest, I don't know why I keep calling it the second, rest, right? This is going to be G, and then return recursive function rest plus first, so this is going to be my return, and I'm going to call it again, and plus first, so this one's going to be O. I should probably put quotes on these, but you're tracing it, so don't sweat it if you don't. Now I'm doing my other call. Okay, is this going to be the last one? Is this going to be the last call?
No.
No. All right, because, and this will throw people off because they'll think, oh, I know what I'm supposed to do now. So do the brute force manual tracing and go ahead and recognize that when you come in here and you're doing this with O, I'm sorry, not O, with G, right? Because I'm doing it with rest. It's not going to be the last one because this is, its length is not equal to 0, right? So first now is G. Now here's where rest is equal to the empty string, right? And so now I'm going to call it one more time because in order to do the recursive function, right, I'm going to do my return is going to be the recursive function call. And then note, you could always go way up there if you needed to based on your paper, right? Plus first, which is G. Okay, so now I have one more, and this is my last one, right? I'm calling it with the empty string. And so now what I'm going to do, since the length is equal to 0, I just do my return 0. So I return 0 back up to here, right? I'm sorry.
Empty string.
Thank you. Not 0, the empty string. I returned the empty string. I was like, wait, that's not going to make sense. Okay, so the empty string plus G, this now equals just G. And so I returned that back up to here, right? And this empty string, this is now G. And so now I have G-O, okay? And now this is gonna return back up to here, right? And now I'm gonna have G-O, and then this is gonna equal G-O-D, and then this I can return back up to the first call, okay? So now my answer is G-O-D, and I can look at this now and I can say, how many times I can answer questions, right? How many times was the function called? 1, 2, 3, 4, right? And I can say, how many stack frames? 4. On the 5th call, or not the 5th call because there weren't 5, right? But on the 3rd call, 1, 2, 3, what was the return value? Do you see how I can answer almost any question about this once I have done this? Okay, right. So this is the kind of thing we're looking for when we're tracing, and you can do any method that you like, and you can permute them if you want to. It's really just, can you answer those kinds of questions? How many stack frames are there? How many method calls are there? What's returned? Okay, those are the most important ones. Okay, do you all have any questions about that process? If I had 2 calls, I could just put another, it would be the return value equals this call plus some other call, right? And I would just have a branch, 2 branches of this going out, so it gets a little bit complicated. And that's what Dr. Fox's method is a little bit easier for, because he has the line number you return to and everything. But I think this is quicker. So, all right, well, there's some paper